Hey everyone, welcome. Let's just jump right into this explainer. Today, we're tackling the ultimate Grade 7 Math Capstone Challenge on rational numbers. We're looking specifically at Math Unit 05, Lesson 04. This is a capstone reflection, which basically means we're pulling together all those foundational threads from St. Paul pre-algebra and the Common Core number system standards. We're going to look at how we combine operations, manage those notoriously tricky negative signs, and use estimation to prove our math actually makes sense in the real world.
Here is our roadmap for today. We'll start with the capstone challenge, then look at the meaning behind the math, explore two paths, one answer, learn about spotting the sign trap, verify with estimation, and finish up with a final transfer self-check. Let's get to it.
Section 1. The Capstone Challenge, bringing it all together.
We're starting right out of the gate as math detectives. Picture this. Your bank balance is exactly $25.50. You get a $50 gift and you deposit half of it. Awesome, right? But then, bam, you get hit with a $12.75 fee. So what's your new balance? This scenario is absolutely perfect because it shows exactly how positive and negative rational numbers, whether they're whole numbers, fractions like that 1/2, or decimals, actually show up in our everyday lives. I mean, it's pretty rare that life only gives us clean, positive integers to work with, right? We have to be totally fluent in moving between all these different formats.
Section 2. Meaning behind the math, defining our terms.
Before we just start crunching numbers to get an answer, let's take a second to anchor ourselves by connecting these real-world actions to their actual mathematical meanings. Starting with a core definition straight from our number system standards. A rational number is basically any number that can be written as a fraction. That naturally includes your integers, your fractions, and those decimals that either terminate or repeat. The big takeaway here, your initial balance of $25.50, that 1/2 fraction from your gift, and that annoying negative fee, they are all part of the exact same rational number family. They follow the exact same mathematical rules, even if they look totally different on the surface. What's super cool about this is how we can map those abstract rational numbers directly back to concrete actions. When you make a deposit, you're performing positive addition. On a number line, you can think of this as moving a distance in the positive direction. When you get hit with a withdrawal or a fee, well, that's negative subtraction, moving a distance in the negative direction. And when you decide to only deposit half of a gift, you're multiplying by a fraction. Translating these everyday words into math operations, that is the real secret to mastering 7th grade math.
Section 3. Two paths, one answer. Arithmetic versus algebraic equations.
Okay, let's look at how we can actually solve this. We've got two different paths that arrive at the exact same destination. You could take the arithmetic approach, doing it step by step. First, half of 50 is 25. Then, you add that 25 to your initial $25.50, giving you $50.50. Finally, subtract the $12.75 fee, landing you at $37.75. But check out the algebraic approach. You can write out the entire story in one single elegant equation, where B equals your final balance. B equals 25.50 plus 50 times 1/2 minus 12.75. It's so efficient, and it really sets you up perfectly for higher-level algebra.
Section 4. Spotting the sign trap, a common misconception. So we found the answer, right? But hold on a second. We're entering the danger zone. There's a classic Unit 2 mistake that a lot of students fall for right at the final step of these equations, losing the negative sign when subtracting decimals. When you're juggling all these different operations, it is incredibly easy to just drop a sign, especially when you switch gears from adding a deposit to subtracting a fee. You might subtract the whole numbers perfectly fine, but totally mess up the decimals. Or maybe you accidentally add the fee instead of subtracting it because you lost track of what the number meant in the real world.
To avoid this sign trap, we can use a really neat trick. Rewriting subtraction as adding the additive inverse. This is a huge concept for the 7th grade number system. Instead of thinking minus 12.75, just think of it as plus a negative 12.75. The rule is simple. P minus Q is the same as P plus negative Q. By turning subtraction into the addition of a negative number, that negative sign stays glued right to the value where it belongs. It acts as a total safety harness for your math.
Section 5. Verifying with estimation, the reality check.
Now that we have our answer, how do we know for absolute sure that we didn't mess up somewhere along the way? We calculated exactly $37.75. But did we put the decimal in the right spot? Did we actually subtract that fee? It's time for a reality check to prove our precision.
This is where estimation comes in, and it brilliantly illustrates how we can assess if an answer is reasonable using mental math. Look how simple this is. Our starting balance was about $25. Half of our $50 gift is exactly 25. So 25 plus 25 gets us to around $50. Our fee is $12.75, which is super close to 13. 50 minus 13, that's 37. Since our quick mental estimate of $37 is incredibly close to our exact calculated answer of $37.75, we can confidently say our answer makes sense. We didn't accidentally calculate $370 or negative $5, right? We know we're in the right ballpark.
Section 6. Final Transfer Self-Check. Leveling up your skills.
All right, it's time for the final boss battle to make sure you've truly mastered this capstone challenge and can transfer your skills to brand new problems. Think about this slightly tweaked scenario for a second. If you earn $25 an hour and get a 10% raise, but then you have a 1/2 hour pay deduction for some fee, what's your net pay for that first hour? Solving this requires you to convert percentages to decimals or fractions, calculate your new base rate, and then apply a rational number deduction. As we wrap up this explainer, ask yourself a few questions to check your work. Did you realize that 10% of $25 is $2.50, making your new rate $27.50? Did you figure out that a half-hour deduction at that new rate is negative $13.75? If you put all those pieces together carefully, you'll find your exact net pay for that hour. Going through these self-checks will leave you totally confident and ready to tackle literally any rational number problem thrown your way. So my final question to you is, now that you can translate the messy, real world into clean algebraic equations, what complex problem in your own life are you going to model and solve next?